Hello and greetings of the day. My name is Ankit Mistry and I am from the group CloudTechHeros. Our group leader is Yongche Ko and we chose the project Resume Scanner and it was like number two on the list that was provided and we implemented the project on AWS. And let us quickly just see what we have made. So this is my CloudFront endpoint, and once we log in we have this beautiful front end developed and you see this page. I'm currently logged in, so I just logged out, and once we log in it tells us to log in with Cognito, and it asks for a email address, and I'll create a new account for this demonstration purpose. And the email ID, I would just enter my email ID and a complex password. Let me just re-enter it, and we click sign up. We receive a code on our mail ID. I'll just quickly refer it. It's 863749. Okay, so now we are logged in, and when we click try it now, it asks us to update my resume, and I upload my resume over here. I'll just select the file. It's residing on my computer, local machine. I just selected my resume and I click upload files. It'll take some time for the process to happen, and as you can see, I've got like three job recommendation. The first one would be for business analyst, and it also says like what percentage of my resume is matching this job. So this is 83%, this is 40%, and this one would be 50%. And if I click view details, I can see the job description. And if I click apply now, it would take me to the LinkedIn ID where this was posted. And we see it's no longer accepting applications because it was of the job was a bit old. The posting was a bit old. Oh my god, I'll just reopen it. Let me go back. So that's how our website is working. And the name of our website is Acemycareer. And that was the demo of the website that we built. So let's see how it is working. And this is the architecture diagram that we followed to like build the website, build the app, we can say. And it has like I would divide it into two parts. So if you see the upper part, that would be the backend developed on AWS, and the below services are used to like develop the front end part of it. So if you see the code, the front end, it was developed on Visual Studio Code. Let me just open the project. Mm, It was on desktop. Is my career. open folder instead. Sorry for that. Okay, this was all the code that was developed by one of our teammate who is an expert in front end, and this code was deployed using Docker. So we used Docker and made an image of this project, and that image was pushed to an ECR repository. So let's go step by step and just have a look at our ECS, ECR, am I bad? The container service. So if you see, this was our repository, and this is the latest image that we are using of the code that I just showed. And once the image is pushed here, we used the next step, if you see in our diagram, was to define a task and run this image on an Elastic Container Service. So to quickly demonstrate that, I would just search for ECR, ECS, sorry, and we used a task definition. So a task definition means like this task would run on the container, and this is our latest task that I gave, and this was the cluster that I made. Is my career cluster. So this cluster would spin up an EC2 instance, and our image would run on that EC2 instance. So if you see the diagram, the ECS service, once it's on, it would create two EC2 instances. So two would be depending on the load on the application. So we have used an auto scaling group, and that would like in turn decide which, like if we need two or just one would be enough for the service to run. And also we used an application load balancer to balance the traffic that's coming onto our app. To just see that, I would say we have to go to EC2 instance, and if we search for load balancers, I have this Acemycareer application load balancer, and we have created a forwarding target group. So ALB is used to like direct the traffic and like keep the app running smoothly. And we also used CloudFront, that would be like edge location, and I'm using my CloudFront ID to log into my, if you see this domain name, I'm using my CloudFront endpoint. So that was about the backend, uh, front end, my bad. And I did not purchase a domain name, so I just didn't find whatever I was looking for, so I decided on using a CloudFront. But if I had purchased, I would have used Route 53 and registered it on that. Okay, so that was about the backend, sorry, front end, and let's see the backend part of it. So what happens is when a user uploads a resume, it resides in our S3 bucket. And prior to that, we have this workflow. So if you see, we have used a third-party application called Appify, which is like scraping data from our LinkedIn, and we are storing the raw data on an S3 bucket. And from that S3 bucket, we have an on-demand uh, Lambda function. So that Lambda function will go through all the job postings and like write it to RDS in a more structured way, so that whenever a user uploads a resume, It could match to the job postings that were uh, up uploaded using the LinkedIn data, the Apify data. So that would be our job postings, the main data where all the jobs are posted. And to just have a look at it, if we go to our S3, we have all these buckets, and the first thing that I mentioned, the job would go into, all the data would go into this bucket, and from this bucket, if we trigger the Lambda function, it would, my bad, I'm looking for Lambda function. Yeah, if we trigger the Lambda function job skill extractor, what it would do is it would pull the data from, get the raw data, which is in CSV format from that S3 bucket, and write it to RDS in a tabular form. So that would be first step. And then when a user tries to log in using the Cognito, he has everything set up. We have his skill, his user records in this table in RDS. And once the resume is uploaded, it goes into the bucket resume upload, and it attaches a user ID which was created by the Cognito to the resume. And once we have resume in this bucket, we have created a Lambda function which gets triggered. If you see, the S3 is the trigger for this Lambda function, and once our resume is here, the Lambda function is triggered, and this Lambda function uses the text track service. And as you see, it's our, this Lambda function is residing outside of our VPC, and that would be because we are using the text track service. So once the Lambda function is triggered, it uses texttrack to scan the resume and send it to SQS. The data would be sent to SQS. It passes the data and sent to SQS, and it, once the data is in the queue, messaging queue, it triggers another Lambda function that would write the data which is in which is in the queue to the RDS service. So now we have the resume data in our resume uploads table, resume uploaded table. So our jobs are residing in job posting table, and the resume uploaded contains the data of the resume, like what skills does it have, what kind of job role does, yeah, what kind of experience does it have, and all those are stored in the resume upload table. And once the data is here, the third function gets triggered, the Lambda function, resume matched. So the third Lambda function that would get triggered would be the job posting matcher, and this is the Lambda function that has the logic to extract the jobs from the job posting table, to, like, it matches the user skills and the job posting, and extracts like whatever job is relevant for that resume, like the user, and it sends out, like, it matches the jobs and like writes it to a resume match results table. So now this table is used by our front end function to display the results that you're seeing here are residing in this table, the job match results table. And using a front-end function, we have like an interface where we can pull these job details and view all the things. So this was like about our project. And coming to the security that we implemented, if you see, we have clearly uh, placed all the Lambda functions in a private subnet. All our EC2 instances are in our private subnet, and our S3 buckets have been given appropriate policies to, but and also like Lambda functions have only those which need read access are given read access, and ones which need write access are given write access. So all those, and also the IAM roles that were given to our Lambda functions are very tight, so that there's no security breach. And yeah, that was it about the project. And I think we have covered like most of the AWS services, like coming from uh, IAM, starting from IAM to ECR, ECS, also EC2, Elastic Load Balancer, and all the Lambda, RDS, S3, and the total combination of all this, like we have implemented, and we got a beautiful result, which is this website. And yeah, that was it about that. Thank you.